Hello everybody, it's Mr. Jeff here, and in this video we're going to be learning a little bit about navigation and sailing. Now, before the time of nuclear-powered aircraft carriers and steamboats and engines and all other kinds of fun stuff like that, boats moved around by harnessing the power of the wind. Now, how did they do this? Well, they used this right here. It's known as a sail. Sails are what they would use to catch the wind to propel the boat forward. What I have here is a small setup, a small mock-up of a square sail that you would probably see on a much larger ship. And it has 4 different lines on it. It has 2 braces attached to the yard up here, and 2 sheets attached to the clew or bottom corner of the sail. Now, all these lines had very important roles on the ship. When navigating a ship in the wind, you had to keep in mind the direction of the wind and how fast the wind is going. So if we look at our little model that we have here, if all the sails are pointing this way and the wind's coming directly from behind you, this mast is doing all the work. This one is not catching any wind. So in order to get the best advantage on the wind, you need to angle your sails like this. So all the work is being done on most of the sails. You would just adjust your sails and go back and forth like that. This is a maneuver called tacking. Tacking is when you are traveling in a direction and you're kind of zigzagging like that. Now, what would you do if you want to go this way, but the wind is coming from this direction? Well, that's when you would use that maneuver, and that's when a very special feature about these sails come into play. So, what you would do is you would steer into the wind, adjust your sails like this. Boat moves along. As the wind is coming across here, it's actually turning these sails into sort of an airfoil or a wing. So much like a wing on a plane, it's pulling the boat in this direction. If you go that way for a little bit, adjust your sails again, go in the other direction. Keep doing that until you get to the point where you want to be. Now, these lines that I just mentioned have jobs on these sails. That's how you adjust the angle of the sails. These up top, the braces adjust the angle of the yard in relation to the wind and the ship, which direction the wind is coming from. So if the wind is coming from this direction and you want to go that way, you can just adjust the sail in this direction to catch the wind from behind it, from this side. Same thing on the other side. The sheets on the bottom adjust how tight or loose the sail is going to be. The reason why this is important is because if the wind is very strong and going very hard and fast, you don't want the sail to be too tight, because then your mast would break and everything would fall apart. But at the same time, you don't want it to be too loose, because then you're not catching anything. Your sail is just going to flap in the wind like this, and your boat's not going to go anywhere. So that's why you need to keep in mind how tight your sail is going to be, or how loose it's going to be in relation to the speed of the wind. Now, I'm going to teach you guys a little bit. So when everybody up, put your arms out like this. You're now a mast on the boat with your yards, okay? Your yards are squared off or straight to the mast, just like this. Now imagine the wind is coming from this direction. I want to go that way, okay? Now we're going to take what we learned and we're going to do what's called the tacking tango. Are you ready? All right, so you start out like this. Adjust your yards in your ship. 1, 2, 3. 1, 2, 3. And you just keep doing that until you reach your destination. A nice little fun day, nice little exercise to do. Now, there are also other readings and calculations being done when you're maneuvering your ship. You're not just maneuvering the sails, okay? You also need to know how fast you're going and in what direction you're going in that speed. Navigation is pretty much the fine art of not getting lost. So if you know how fast you're going, in what direction, and for how long you've been going in that direction, mariners can, with some accuracy, determine their spot on a map. Now, in order to calculate speed, you're going to use this tool right here. This is what's called a chip log. Now, chip log is where we get the term knots from. If you ever wondered why on a sailing ship or any ship they calculate speed in knots, this is the reason why. It's made with a couple different pieces. You have the chip, the log, and the knot line. Now, how it works, you would take the chip, throw it over the side of the boat, just like that, and as the boat moves along, the chip stays still, and the line rolls out. And you would let that line roll out for determined amount of time, usually 30 seconds. And then when you wind it back up, you count the knots in the line, which is where we get the term knots from. Now this one is a smaller version. It's about half the size of an actual chip log. The knots would usually be about 6 feet or 1 fathom apart. These I have are roughly about 3 feet or half a fathom. So after we have our information, we can start doing our calculations. So let me pull up my calculator here. All right. So here we have the little formula that you can use. So I'll go ahead and pause. You can go ahead and pause the video so you can copy all those numbers down. And we are going to see how fast we were going. You can follow along in your field journals and your field notebooks. Okay. So assume in 5 seconds, we took account of 5 knots. Okay. So that means that we traveled 3 feet in 5 seconds. Or 15 feet in 5 seconds, because 5 times 3 is 15. So 15 feet per second for 5 seconds. Now, how many feet per second is that? Well, that's 3 feet per second. We just take 15 divided by 5, and that gives us our feet per second. Now to convert it into larger numbers. There are 5,280 feet in a mile and 3,600 seconds in an hour. So we take 3 feet per second, multiply that by 3,600. And then we get 10,800 feet per hour. All right. Now we need to calculate that down. So this divided by 5,280 feet will give us our miles per hour. So divide by 5280. So we were going roughly about 2.5 miles an hour. Now to calculate that in knots, so we can put it all in nautical terms. 1 mile per hour equals roughly 0.87 knots. So what we want to do is multiply 2.5 times 0.87, and then we get 2.17 knots. About 2.17 knots. So that's how fast that boat was going. Now, when you're taking all these calculations, you need to remember it. You need to write it down. There's actually a special tool that they would use to actually write down these or keep track of these calculations for each shift on the boat. And that is this right here. This is what's known as a traverse board. Your traverse board has 2 different sections. You have your directional reading up top here and your speed reading down on the bottom. Well, each half hour, what they would do, they would take a speed and a direction reading. They would put the peg in the appropriate hole. And then at the end of 4 hours, the next shift can come on, take a look at these calculations and relate it to the calculations that they take, and then they can find their position on the map. Now in the next video, what we're going to do is I'm going to show you guys how to make another tool that mariners would use called a quadrant, and that's going to be pretty fun. So thank you guys for watching this video, and we'll see you in the next one.